Okay, so this one is our session number 2 on spherical trigonometry. So we are going to start our main topic today. So last session is just a prerequisite of a spherical trigonometry. So the most important things that we learned in last session is regarding a spherical triangle uh, that we require in mathematics subject is that every triangle have total 6 components. So when we have to draw a spherical triangle, a rough sketch we draw like this. So this is the one side of the triangle. Let's say this is the other side of a triangle and this one is the third side of a triangle. So here are the vertices. This is the vertex A, say. This is the vertex B of a triangle and this is the vertex C here. So A, B, C are the vertices of the triangle and the sides are not a straight line, they are curved lines. Okay, that way. So actually they are the arc of the great circle. They are the arc of the great circle. Generally they are smaller arc of the great circle. Why? The reason is what is the maximum length of the side? Yes, anyone? What is the no, I am asking what is the maximum length of the side of a triangle? Or you can tell me the minimum and maximum length of the side of a triangle possible?
Sum of the two sides.
No, I'm asking what should
The
be the
180 and 0.
Yes, that's the correct answer. So this length BC, actually this capital ABC are used for the vertices or the angles, while small a is a side, small b is a side opposite to the angle B, small a is opposite to A, and small c is opposite to that angle C there. So this is the capital C and that's a small c there. That's the difference there. So small lowercase alphabets used for the sides, capital alphabets or uppercase are used for the angles. Already we discussed about this side, say A. Okay, so any side of a triangle is always less than 180 degree. Okay, it is generally between 0 to 180 obviously. So any side of the triangle is always between 0 to 180. What about angle? What about the range for the angle? So what is the minimum angle and maximum angle possible in the triangle?
0 to 180.
0
and 360.
0 and
540.
540.
okay, so that's not a correct answer. Again, I said 180 degree only. What is a 540? You are saying sum of the angles. Okay, there are different properties. This is regarding every side and angle is always up to 180 only. Okay, that is a property. But the other properties you are telling me about regarding small a plus b plus c. Small a plus b plus c is always less than 360. Is it? Side. Sum of the sides of the spherical triangles are 0 to 360. You can imagine maximum spherical triangle as a great circle only. That great circle itself a spherical triangle, and if you see the length of perimeter of that spherical, it is just 2 pi r. If r is 1, radius is 1, so 2 pi, that is 360 degree. 360 degree is the maximum sum of the side. So this property is not required actually. And you are saying about 540 degree is regarding this one, capital A plus B plus C is 540 degree. Okay, so this is another property, but the most important thing is here. This is important for us. We're saying the side and angles are always less than 180 degree. Okay, they are 180 degree. Never we are given any component greater than 180 degree there. So your answer should be always up to 180 degree only. If your answer you write 240 degree as answer, you are wrong there. Okay, you are wrong there. Obviously, your answer should be up to 180 degree. That is one thing. Now, there are two trigonometric functions which are defined in our circular functions with respect to the circular function. That is in a trigonometry we have the sine and cosine. If we observe in the range 0 to 180 degree, so our theta, that side or the angle, both are up to 180 degree. So I will say theta equal to 0 to theta equal to 180 degree. That is first two quadrants. Okay, that we have. in which if you observe, let I give you a simple example here. Say, can you tell me the value of cos 30? Yes,
Under root 3 by 2.
correct. What about cos 150? Cos of 150
minus root 3 by
minus
2.
root 3 by 2. Good. So that is correct. Now I will come to the next here. Sin 30.
1 by 2.
1 by 2 is the correct answer. Sin of 150.
1 by 2.
1 by 2.
That is also 1 by 2. Here is a problem now. This is actually a problem for us. Why this is the problem? Because you will observe sin 30 is also 1 by 2 and sin 150 is also 1 by 2. So the problem occurs when we take, say, sine inverse of 1 by 2 or sine inverse of 0.5. Sine inverse of 0.5, if we want to write it, we cannot write only 30 degree, because yes, the angle always up to 0 to 180, and in this range 0 to 180, sine inverse of 0.5 can be a 30 degree or 150 degree. So there is a case of ambiguity, or there is a case of deciding the angle, because the angle can be, the answer can be a 30 degree or can be a 150 degree, but we have to give only one answer. We have to give only one answer. So that ambiguity we have to solve it. Our aim, this ambiguity is not with a cosine function. Is it clear? Because if you know sine 60 is half, okay, sine 60 is a half, and sine, sorry, my mistake, cos 60 is a 0.5, okay, and cos 120 is also 0.5, okay, sorry, minus 0.5 there. Cos 120 is a 0.5, cos of 120 is a minus 0.5, and because of that, cosine have that sign difference. So when we take cos inverse of root 3 by 2, cos inverse of root 3 by 2, we have only 30 degree as answer. We cannot say whether it is a 30 or 150. We don't have any problem there. Cos inverse of minus root 3 by 2, cos inverse of minus root 3 by 2 is 150 degree only. There is a unique answer. There is a unique answer for this cosine function. So cosine function doesn't have any issue. There is an issue with the sine function only. That sine function have a problem. When we take a inverse, when we take a sine inverse, we generally get two angles in the range 0 to 180 degree. We get two angles in range 0 to 180. So this ambiguity we have to solve it, or we have to decide the correct angle. And to decide the correct angle, generally one property is used, and that property of a spherical triangle that I told in the last session, that is a property number 6 only. Yes, anyone remember that property? What is that property? There is one property we can use it to decide which angle is there, which is the correct angle. So that property is, yes, anyone?
Greater side has greater angle
The
opposite.
greater
Very
side,
good.
greater
the
side
greater
Nice,
has
angle.
the
correct.
greater angle opposite to it.
Correct, correct. So greater side have a greater angle, have a greater angle, okay, greater angle. So this is the property that can be used to solve the ambiguity, and we can resolve the issue of a sine function, okay. But when the problem is there, there is some cases where there is a problem. For example, suppose you are given all the three sides of the triangle, and question is find the angle. Now, using the three sides of a triangle, you obtain that angle, and that angle, suppose you calculated with the help of sine inverse formula, with sine inverse. Then there is a problem. Because you don't have any pair of the side and angle to compare, and because of this, there is a need of Haversine function. Remember, 99.9% examples solved without Haversine. Okay, I'm saying 99%. Okay, you can say just 99 at least. 99.9 I will tell you. Near about all examples we can solve without Haversine function. Okay, there is a very rare situation that time the sine rule is not applicable, and sine function that remaining formulas will not work, and only you have to go to the Haversine. So in our syllabus, whatever we have the questions, whatever all the examples we have, you can solve each and every problem without Haversine function also. So choice is yours, because generally I give this example to in Laplace transform also, that whenever we have two paths, now you are not in the campus, otherwise I ask this question. For example, so I ask from hostel you want to come to the college, so which path you will select? Okay, so that way. Or indirectly, now you don't know the campus routes here, so let I ask you another question. Suppose you want to come from Mumbai to Pune. Okay, Mumbai to Pune. So and you are selecting only by road. Okay, you have to come only by road there. So then obviously you will directly find a shortest route, no? You will find a shortest route from this Mumbai to Pune, and you will come by that way, by road only. You will not go like you will not go from Mumbai to some Hyderabad and then Hyderabad to Pune. Okay, that way. Unnecessary, you will not go that way. Unnecessary, obviously. So like that, in Haversine, what happens? You have to do little extra calculation. Okay, little extra calculation. So you can avoid it. No need to do it. But if you have interest, if you have interest, you can go from Mumbai to Hyderabad, and from Hyderabad you can come to the Pune again. So that way also you can come. Okay, so choice is yours at the end. Choice is yours. I will not say that you should not use. You can use Haversine also. Choice is yours. So we'll see how that sine function is completely avoided in Haversine formula. And in Haversine formula, it is a free from sine function. So there is no ambiguity. Directly you get either 30° or 150°, only one angle. So there is no need to use this property. Greater side have the greater angle. Okay, greater side should have the greater angle. That property, no need to use. Without that, you can directly get the answer. We'll see the example, it becomes more clear. So let me first see what is the definition for this Haversine function. Okay, so for that, just a minute. First, there is a function known as a versine of A. Okay, versine of A. It is a 1 minus cos A. So we have a cos theta function. 1 minus cos theta is defined as versine A, and Haversine means we have to half of this. So just we have to half it, so it become a Haversine function. So you'll see Haversine of A is half of a versine, half of the versine of A, and that is 1 minus cos A upon 2. So just you should remember the formula for Haversine of A, half of A is 1 minus cos A upon 2. This is the half function, and this function, when we use in the formula, instead of sine function, there is no ambiguity. So what is the minimum value of Haversine and what is the maximum value of Haversine? You will see here Haversine of a 0 means in the range 0 to 180. Haversine of 0 is a 0, Haversine of 90 is a 1 by 2, and Haversine of 180 is 1. So we get exactly unique value between 0 to 1 for each angle from 0 to 180. Okay, so there is no case of ambiguity. So a simple formula, just to remember, Haversine of A is 1 minus cos A upon 2. That's one only. So first we'll solve two questions with cosine formula, and then we'll solve the examples with the Haversine also in the today's session. So any doubt in a Haversine, anyone?
No, sir.
No doubt. Okay, so let me move here. uh, this is the one of the most important slide for you. Remember, already I given one example that you have to come from Mumbai to Pune, and you will select a shortest path, is it? So that way only I will tell you, to solve one numerical there are more than one method. So you have to select a best method or the shortest method. Okay, the method which give you the answer quicker. So I will tell you which are the important here out of this. Just I will take okay. So uh, at the end of the this topic, spherical trigonometry, that time also we'll discuss about it. But right now I will tell you, when you come across a right angle triangle, this right angle triangle or quadrantal triangle, we'll discuss about this. Okay, remember this is actually the slide I kept at the last of the session, but I want to tell this at the beginning also. Okay, so you will come to know what is a right angle triangle, what is a quadrantal triangle, and then for this triangle, it is better to use a Napier rule. Okay, Napier rule. Next, when three sides or side angle side is given, okay, it is better to use a cosine formula. We can use Haversine also, but I will tell you, you should use a cosine formula. That's better. Okay, whenever triple A or ASA given, means all the three angles given, angle side angle given, it's better to use a polar triangle. Use a spherical polar triangle. So this is a third thing that you should use. Next, whenever in the pair of sides and angle, one component is missing, better to use a sine rule. Okay, now when you use a sine rule, obviously which property you have to use that to remove the ambiguity? Greater side have the greater angle. Okay, so greater side have the greater angle, use that property and solve the ambiguity. Okay, so when you use a sine rule there, sometimes in cosine formula also, if you use sine inverse there, that time also you have to use that property, that is greater side have the greater angle. And lastly, in four consecutive parts, if one of the inner part is missing, we use a cotangent formula. But I will tell you right now how many cases I given. 1, 2, 3, 4, 5. 5 cases are there. These are the 5 different cases. Out of that, maximum examples or all the examples you will solve by this Napier rule, that is 1. Next, cosine rule, second. Third, polar triangle, and fourth, sine rule. So only these 4 cases are the most important cases for you, because all the examples you can solve with the help of these 4 formulas only. Okay, all other methods are the optional methods, okay, like Haversine formula or cotangent formula. So that can be used and you will get the same answer there. Okay, you will get the same answer there. But obviously, if you came across the ambiguity and you are not able to solve that ambiguity, you should proceed to the Haversine then. You should proceed to Haversine there. Okay, so that about the 4 important methods. Even though I say there are 4 important methods, so all these methods I because of there are extra methods to solve the same cases. Near about 8 methods I have taken there. Total 8 cases I have taken. One by one we are going to complete it. So today we will look only for the first case, case number 1. Whenever we are given triple S or SAS. So come to the next here. So here is our case 1 and 2. What is the case 1 and 2? You will observe here. The case 1 and 2 is SAS or triple S. What is SAS? Side angle side. You will observe given, given, and given. So what is this? Side is given, angle is given, and side is given. When you are given SAS in this format only, okay, that means 2 sides and included angle is given, or triple S is given. Triple S means side, side, side. So whenever the case is there, SAS or triple S, yes, we can use a cosine formula or a Haversine formula. So I will show you the cosine formula first. Or anyone knows what is a cosine formula? Can anyone tell me? Cos of B. Which B we have to take? Angle or side?
Side.
Yes, correct.
The
Cos of
side.
side, cos of opposite side is equal to
Cos of
Cos of
angle
B.
cos
B.
of capital
Cos
B.
of B, sine of adjacent side 1 into sine of adjacent side 2.
Okay, good. So let I show you that formula. So cosine formula is like this. So this cosine formula is this one. You can remember in terms of notation with a diagram, or you can remember in words. How you can remember in words? Cos of opposite side. Now why it is opposite side? Because the angle which we have to calculate, or the side which we have to calculate, that should be considered as opposite side. So here the pair of angle and side is taken, and so cos of opposite side is equal to cos of angle, because there is only one angle, into sines of adjacent side into sine of sines of the adjacent side plus cosines of multiplication of cosines of adjacent side. So that way you have to by heart it. So create in this formula in Word and you should by heart it. You should remember it because all the formulas are without proof here. We're not going to prove any of the formula. So this is the cosine formula that can be used to compute the missing components of the triangle. That is one thing. Next, or there is another formula, and that formula is Haversine formula. So we can use a Haversine formula. So this Haversine formula is generally free from this sine function. It's free from a sine function there. So you'll observe Haversine of angle. Haversine of an angle. Here cosine of a side is there. Okay, but here in Haversine we have the angle. Haversine of angle is equal to cosec of adjacent sides, multiplication of cosec of adjacent sides into Haversine of that opposite side minus Haversine of difference between the adjacent sides. Now this a minus c, this is, you can read just a minus c. Why this minus sign is written this way? The reason is only you have to take the positive difference only. Means if a is greater than c, you will take a minus c. But suppose c is greater than a, you should take c minus a there. That way. So that only thing is written here. The difference of the a minus c is always positive there. So you can remember the formula. Haversine of angle is equal to multiplication of cosec of adjacent sides into Haversine of opposite side minus Haversine of difference of the adjacent sides. So that way you have to by heart it. So any doubt in the formulas here? Because we'll not go in the derivations. We will see the examples then.
No, sir.
No? Okay, so you have to remember the formulas. There is no alternative only. You should know the formula. So just you have to focus on SAS and SSS. If SAS and SSS is there, better to use a cosine formula there. So question number 1. Now there is no need to write, I think, because everything is in the PPT. It is a solid example. But I will suggest you should have a calculator with you every time in the session. So you can cross-check only the calculation. Today only I will upload one tutorial on this spherical trigonometry so that side by side on each method you will solve at least 2 examples. If you do 1 or 2 examples on each method, I will tell you you will easily do these questions in exam also, because it's not so difficult. It's a very simple topic that you have. So I will give just 2 questions or 1 question on each topic so that you can practice that question in the tutorial. Okay, so I'll upload it. So in a spherical triangle ABC, so what is the things we are given? Yes, what is the small a?
There's all the sides.
Side.
All sides not correct. So you should
2 sides, 1 angle.
Yes, 2 side and angle is given. Remember, you should able to differentiate between small alphabets, lowercase and uppercase. Okay, so you will find here that question is find small c and capital C. Okay, so all 3 sides not given, 2 sides and included angle is given. So this is the form of SAS. Okay, so if you see the diagram, so first better to draw a rough diagram. In rough diagram, you can draw 1 arc, 2nd arc, 3rd arc. Okay, and just write which is given. So just give the notations. You can start giving a from any place. So it is capital A, B, C.
Sir,
Yes.
74 is the angle, no, sir?
74 is angle. Oh, yeah, correct. So I think I have to change the notation then, because obviously I missed the wrong notations then. Here should be then capital C and find small c is a 74. Let me see what is the calculation I done there. So depending on, we'll change our question now. Okay, so probably small c is a 74 and we have to find capital C. Okay, capital C. So reverse can be a possible. Yes, I will tell you, if capital C is 74, you have to do the different way there. Okay, no issue. So which formula we should use? Yes, anyone? Or should I correct first?
The
Okay.
cosine
Cosine formula.
Yes, cosine formula. So cosine of small c or capital C?
C.
Small c.
Small c.
Cos of small c is equal to
Angle capital C.
Okay, cos of
capital C
capital
into
C.
sin A sin B plus cos of A into cos of B.
That's one good. So that is
Cos A, cos B.
that is only the main part. Just I will correct it. I will check what is a capital C is calculated. So here is a correction. This is a small c and there is a capital C. My question is wrong only. I will send the corrected PPT at the end. Okay, because it may happen because I prepared this PPT first time only because
Sir, but calculation is done for small c.
Calculation is done by small c, sir. The question
calculation
is the diagram is wrong.
diagram is wrong. Okay, so I will change the diagram then. Okay, thank you. So question is done for small c. Why here it become capital C then? Okay, because it may be, yeah. Okay. So these are few mistakes that happen when you type it, but yes, when you write it, you should write it properly. Okay. So this is the question and the diagram is wrong. So let I draw the correct diagram also. So instead I will do a correction here. The correction is yes, already all you know this is not correct. So this should be a 74 degree. Okay, so capital C is a 74 degree given and we have to find out a small c. But yes, here is only small c is there. Small c is there. AB is a small c. And that formula then, just a minute. Here is the formula. Cos of small c is a cos of capital C into sin A sin B plus cos A cos B there. Okay, so that's formula. This formula you should remember. Just replace the angles now. We replace these given things. Okay, because we have to find out the cos of that small c. We have to find out only. And now you have calculator. Use a calculator properly. You should be in the degree mode only. And cos of 74 you can calculate and you can replace that value. Use of calculator is a very important. If you put a wrong values and you'll get wrong answers then. Okay, should not do the silly mistakes. So next step, just these values are replaced from a calculator. Okay, you can cross check these values. If you have the doubts, yes, you can ask. And at the end, we get a cos c is equal to some number. And this number is always between 0 to 1. Remember this or minus 1 to plus 1. Sorry, minus 1 to plus 1. So c becomes cos inverse. So if cos c is this one, next c becomes a cos inverse of that. And now we know cos inverse gives us exactly unique angle between 0 to 180 degree. And we get a required answer then. And that answer is 49 degree. Okay, now on calci, yes, 49.45 degree. You will get the answer. Someone given the answer, I think Chirag or okay. So he given the answer 49.45. Remember, generally the angles given in the form of, yes, you can write 49.45 degree as answer in the exam also. I'm not saying that's wrong. So in the exam also you can write this answer this way, that small c is a 49.45 degree. Okay, but if you want your answer in degree and minutes, so I already told you have to just press shift button, and after that you have to press that button of degree, minutes and second, that is below square root. If you press it, it shows 49 degree 27 minutes it shows. So somewhere it is a mistake made by, I think, Chirag. Chirag, is it 49.45?
It's 49.54.
54. So if you do these silly mistakes, then your answer is wrong there. Okay. Remember, let I check cos inverse only. Shift cos inverse of 0.648920. It's better. 49.54 is the correct answer. Yes, 49.539. Okay. So C becomes this is not a correct answer here. Whatever the answer given. Okay, just I will erase it first. This is the wrong angle given there. So the angle is you can write 49.54. Okay, because the next decimal is more than 5, so you are rounded up. So 49.54 degree. 49.54 degree is the correct answer. See, and if you press now that thing, shift, and that you get 49 degree 32 minute and 23 seconds or 23.19 seconds. So you can make it as a 24 second also. 24 second means this way also you can write it. Number of ways of writing the answer. This is one of the way of your writing the answer, or your answer small c can be 49 degree 32 minutes, and I will say 23 seconds. 23.19 is there, so but I will take approximately 23 seconds. So this is also the answer. This can be your answer. You can write answer in any of the form. Okay, and lastly, if you're not happy with minute and second, you want to convert minute, the second to the minutes, your answer can be in this form. Okay, so choice is your one of the answer you should write it, but by mistake also, Chirag, if you write this answer as 49.45 degree, there is too much error. Remember, these errors cause a very big problem in a navigation. In navigation, this point, even though you say there is a decimal problems, these decimal places, first decimal is obviously most important. He says 49.45 and here is a 54. So actually error is a 0.09 degree. 0.09 degrees, that is error, and that is considered as a very big error. Okay, so roughly in second decimals, if there is error, that's okay in second decimal, but first decimal, if you say 49.54 degree, so this first decimal is the most important, that should be matched, and second decimal near to that 54 is there, so your answer is 53 or 55, that is okay. So 49.53, 49.54, 49.55, that can be the answers. So generally the more error is not accepted there. Got it? Any doubt?
No, sir.
Okay, so I hope you may observe the questions are really simple. Okay, and mainly we solve the problems whenever we are given these three sides or sides and included angle. Okay, that about the question number 1. I'll move to the question 2 here. So example 2, in capital XYZ triangle, so we have to find out capital Z and a small xyz is given, is it? So let us check a diagram whether in this case the diagram is correct or not. So yes, small xyz is written and capital Z we have to calculate, correct? Okay, so diagram is correct, is it?
Yes, sir.
And this is the formula which is written. Now cos of small z is equal to cos of capital Z into sine of these adjacent sides plus cos of adjacent sides, cosine of adjacent sides. Okay, that is a formula. Just replace the values. It's a so simple things that you have. You can replace it here only, and at the end you can solve it for cos z. That way also you can do it. And here you get 0.880 and cos inverse then, and you get the required answer. If anyone have a doubt, yes, you can ask. Questions are obvious, so I'm not doing here, and I'm telling you have this PPT with you, so you have to cross check these calculations. Okay, and if you have the doubts, yes, you can ask in the next session also. Any doubt? Can we move to the next then?
Sir.
Yes, sir.
Okay.
Sir.
Yes.
Sir, how many decimals we have to take, sir? Like for how many decimal points?
You have a calculator. Why you are worrying? At least 5-6 decimal you can write it easily. Is it?
Yes, sir.
Because you have calculator. Remember, no need to show too many steps. Just see, this is the formula written. In the formula only you can replace the angle. And when you just write these values, or when you write these values, and next step is multiplication. So minimum steps you should write it there. And decimals, obviously, see, the more decimals you will take, your answer becomes more accurate. Is it? But only the effort that you have to do is you have to write that decimals on the paper. Is it? Yes. Now Saresh is asking, instead of small y, can I write zx? You can write it zx, not an issue. But in the exam, in the question, you will given all the things in small alphabets and capital alphabets. Okay. So while writing, yes, you can use that side by zx or side by capital AB, side AB. but instead of side AB, it is written side C. What it? In the textbook, everywhere, the standard notations are followed. So the data will be given in that form majority of the times. Okay. You have to convert in the, you can write in the side form also, but it is not, that is not wrong. That is also correct. Is it clear, Saransh? Is it Sharash?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay, so I'll move to the next then. Okay. So question number 3 is on the screen. Can you see what are the things we are given? And triple S or SAS?
Triple S.
Okay, yes, triple S, SSS, all the sides given. Okay, and the question is calculate capital P, capital Q, capital R. Remember, such a lengthy question generally not come in the exam. In the exam, generally you the question is find one or two missing quantities. Okay, remember, in some question paper only one angle they will tell you to find out. In some cases they may tell you to find out two angles. Okay, you have to repeat the process only. You have to repeat the process. So that questions are of 5 marks there. So, but all the three is definitely a lengthy there, because, and now probably I done the question with Haversine there just to show you how that Haversine works. So all three sides given here, and we have to find out the three angles there. We can start with any angle. Suppose we have to find out capital P. We have to find out capital P. So we'll start with the Haversine formula. So Haversine of capital P is equal to, so Haversine of angle is equal to, if you remember, I think it is a cosec of adjacent sides, multiplication of cosec of adjacent sides into Haversine of opposite side minus Haversine of a difference of adjacent side. Something like that is the formula. Let me check. So here is a formula. The formula you should remember like this. Haversine of angle is a cosec of one adjacent side into cosec of other adjacent side into Haversine of opposite side minus Haversine of the difference between adjacent side. This is the formula that you can by heart in words also. But I will tell you, same question, this question number 3 can be done by cosine formula also. So choice is your whether you have to come from Mumbai to Pune direct, or you have to come from Mumbai to Hyderabad and then come to Pune that way. Okay, I'm giving this example again and again to tell you that both ways gives you the same destination. Only the difference is here you have to do a more calculation. Okay, that's only the difference. So here is the formula for calculating capital P. Case 1 we taken only capital P. So it's written in terms of capital P with respect to capital P, I will say. Now we'll replace the given things, that is a small pqr. Small pqr we have to replace in this formula. So before that we calculate q minus r. Remember q minus r. So that you have to take it with larger minus smaller only. Right now q is greater than r. Small q is greater than small r. So this q minus r only we taken. Suppose r is greater than q, then we take r minus q, because this is the symbol. This symbol indicates the difference is always positive. That is q minus r. So which comes 48 degree 2.2 minute. Now here is one problem. Few of the students have the issue in subtracting the angle, because this angle is not given in entirely in degree. Now there are two ways to do it. What you can do it, you can convert all these three sides in degree only, and you can do the calculation with respect to degree throughout. Or you have to use this degree minute second tab. With using that tab, you can do the calculation in the same format only. I hope you are getting. For example, suppose you have to take 62 degree. Suppose you have to do this subtraction. Okay, let me take this subtraction. What are the steps I will tell you. So q minus r. First you will press 111. Once you press 111, you press that tab below square root having degree minute second. So I press that tab. So you get 111 degree. Then you have to press 35.2 directly. 35.2 I pressed, and I pressed the same tab. So I got 111 degree 35.2 minute. So for that I will press equal tab. Now I will press equal tab. In equal tab, it shows now 111 degree, 35 minutes, and 12 second probably. Okay, 35.2 minutes second. Okay, no issue. Minus minus 63 degree, 33 minute, and then I'll press equal. It shows 48 degree, 2 minutes and 12 second. So 12 second, if you want to convert again, you have to divide 12 upon 60. Is it 12 by 60, or it gives us some error, I think. So let I shift and same tab.
0.2.
48.03. So better what you can do it otherwise. Okay, this is one way, or the other way is 48.036. But better what I suggest you, you can do one thing. When you are given these questions, step number one, you can do this also, so that you will not make any mistake. Convert all these angles, whatever the angles you are given, convert them only in degrees. That's better. It will not keep any confusions. For example, small p will become, just if you press use a calculator, I will use a calculator, 62 degree, 62. Now what is the problem? Actually the calculator, if you use if you want to use a calculator, you have to convert at 0.1 second, sorry, 0.1 minute, 62 degree, that 0.1 minute, you take like this, 62 degree, 10 minute, and now 0.1 minute is there. How to convert 0.1 minute to the second? Yes, anyone?
6 seconds.
Into 60, 0.1 into 60, that is 6, correct? 6 seconds. So this way you have to enter the data. You have to enter this data, not this data directly. Calculator will not take this data. Just I seen there is an error. There is error when we do the subtraction just by taking 35.2 minutes. You cannot put the minutes in a fraction on calculator. So what you have to do it, you have to convert everything in degree, minutes and second. So P is there, small q becomes then 111 degree, 111 degree, 35 minutes and 0.2 minute, we have to convert in second. So is it 12?
Yes, sir.
And small r then, small r is 63 degree, 33 minutes, it is a direct there, there is not an issue. So whenever there is point minutes, like 0.1 minute, 0.2 minutes, we are just multiplying by 60 there. If you multiply by 60, we get seconds there. And now you do a subtraction, q minus r. If you do this subtraction on calculator, you will get exactly the same answer. Okay. For example, you are putting 111 degree, 35 minute and 12 second minus 63 63 degree, 63 degree, and 33 minute. I made some mistake. Sorry. I forgot it to press 0 second there. So these are the mistakes that happen. You should practice on calculator, remember, otherwise what happens in the exam, you will make a mistake. So you should practice and you should cross check all this calculation. Yes, you have to press 0 second here. Whenever there is no second on calculator, you have to press 0 second there. Okay, that way. So I pressed now 111 degree, 35 minutes, 12 second minus 63 degree, 33 minutes, 0 second. And I got answer 42 degree, sorry, this q minus r is a 48 degree, 2 minute and 12 second I got. Is that same answer you received by that method? Shift. Yes, that is correct. I think direct also it works then. Direct also works. I think without conversion also it works. 48.04 degree. So this is the answer, or this is the answer. You can keep any one of that. I hope you got how to calculate q minus r. Any doubt, anyone? Direct also it is working, okay, without converting that minutes to the second. That also works. I checked here. So just replace all the values in the formula now. Whenever you have to calculate, say suppose you have to calculate this Haversine of 62 degree 62 degree 10.1 minute, how you will calculate? Yes, anyone?
1 by sine.
No, it is not 1 minus sine. It is 1 minus. If you have to calculate this calculation, how you will do this calculation?
1 minus cos of that
Yes,
angle.
1 minus cos of
Upon
62
2.
degree 10.1 minute divided by 2. So this is the calculation. You can do it on the rough there, on the side work. So this calculation and similar calculation you can do it for this also. This 1 minus cos of 48 degree 2.2 minute. That also you can do as a side work upon 2. And then you can replace that value. Okay, so this calculation you have to do it. So I will show you here. So that answer is written directly here. This is actually 1 minus cos theta upon 2. 1 minus cos theta upon 2. Now we get here Haversine P, we get finally Haversine P, but we cannot take P equal to Haversine inverse directly. We have to write Haversine P as, yes, Haversine of capital P as 1 minus cos P upon 2. Is it? Yeah, correct. So 1 minus cos P upon 2, and then P becomes cos inverse of 1 minus 2 into that. Okay. So it is simple. I dropped one steps here. So these steps you can do it. First you have to write it here as 1 minus cos P upon 2 is that value that I say as a theta. Not theta, say x. Okay, I will take that as x. Okay, this value is x I said. So you'll observe it become 2x. 1 minus cos P is a 2x. So cos P becomes uh, 1 minus 2x, and so P becomes cos inverse of 1 minus 2x. Okay, P becomes cos inverse of 1 minus 2x that way. Is that clear? And this calculation also you can do it on calculator. Okay, so this multiplication and that, all that things you can do it on calculator, and then just you have to take a cos inverse on a calculator and you get a unique answer there. There is no ambiguity case here. So the answer of cos inverse of this is 40 degree 44.7 minute. 40 degree 44.7 minute. Final answer can be written in only degree. It can be written in degree minutes. It can be written in degree minutes and second. All three are the correct ways of writing the answers. Okay. Don't think in which format I should write the answer. Your answer can be in any one of that three formats. Got it? So you may see the difference now between cosine formula and the Haversine formula. Yes, Haversine formula avoids the sine function to avoid the ambiguity, but it increases our calculation. It increases our calculation. So similar way, we can find out capital Q and capital R also. Only we have to start with the Haversine of capital Q. Haversine of capital Q is equal to cosec of P and cosec of R into Haversine of Haversine of small q, correct, and into
Minus
Haversine
Haversine of
P minus R.
R minus. R
Okay.
minus.
R minus P. Okay, good. Because R is a greater than P. That way, good, very good. So this is the way you can complete the remaining also and cross-check your calculation. So here are that answers. The answers for capital Q and capital R. Everything is done by Haversine there. So that is question 3 only, because all three angles we have to calculate. So it become a lengthy there. Okay. So whatever the time we require to calculate capital P, same time probably we require to find capital Q and capital R. So it become 3 times repeated process only. And last example on this type. So where we are given side angle and side, and we have to find out the remaining 3 components there. And this question also can be done by cosine formula. You can do it without Haversine. That is your choice. If you want to use a Haversine, yes, you can do this way then. Okay. And here also you have to do the same thing, because suppose we are given small b, small a and capital C, which component we should find first, because we cannot find directly capital A. Capital A we cannot find it. Yes, we should find out
Capital C.
a small c. We should find a
Small
small c first. Okay, small c we can find out it first, and then with the help of that we can go to the capital A and capital B. Okay, that is a way. So just you have to follow the Haversine formula. Haversine of small c is equal to that way, and replacing, and you get the angle this way. Okay, this way you can get the required angle, and then you can go for capital A and capital B with the help of Haversine formula. So I suggest this is the final answer. Whatever the examples in the PPT, they are the most important example. Only if these examples you do it, okay, you do it on paper your own, then also you can solve any problem in the final question paper. But if you want a more practice with some other questions, yes, you can solve the tutorial then. So in tutorial, I will not give the big tutorial now, because I know there is a very short duration for you. Okay, there is a very short time left for you for the final exam. So it's better you should practice, you should understand one example only. If you understand one example, you can solve the similar problems easily then. Is that?
Yes, sir.
So any doubt for the today's session?
No, sir.